I'm Alan Hall, host of the Uptime Wind Energy Podcast. Wind turbine icing is a massive problem. Most wind turbines in the U.S. and Northern Europe are installed in locations that are susceptible to icing, and yet a significant number of the wind turbines do not have any de-icing system. Our guest today is Aaron Dupuis, Director of Marketing at Phazebreak Coatings, and Phazebreak Coatings produces Neinice, the ice-phobic coating that is being used on wind turbines to keep them humming during icing conditions. The coating contains microscopic phase change materials that absorb heat from the liquid water as it freezes. This heat prevents the water from freezing solid, and the ice does not form easily, and it sheds off the surface. I'm really interested in learning more about Phazebreak during this podcast. Aaron, welcome to the program.
Thank you very much, Alan. I really appreciate it.
So we all know from the icing events that happened in Texas, because that's a very noticeable event, that obviously Texas does not have de-icing systems on the wind turbine blades, as they readily admit. And why would they, honestly?
Why would they? You wouldn't expect you'd need it.
No, you shouldn't really need it. It's once every 100 years they may have an ice storm, but they've had 2 ice storms in about a 5-year period. So it is actually a lot more common than we thought. And that left to hundreds of thousands and millions of dollars lost, and deaths and all kinds of horrible things happened there. That drove the industry to change a little bit, right? So we're now seeing some more interest in how do I protect these wind turbines that don't have a de-icing system.
We were lucky enough at the time to have just coated half the turbines on a farm in Oklahoma. We had 50 coated and 50 uncoated in Oklahoma during that same Valentine's weekend winter storm. And what we ended up seeing, our customer gave us data back, and we saw a 109% improvement in the coated turbines over the uncoated. And many of them kept turning and came back online earlier than the uncoated varieties. And again, so, Oklahoma, Texas, these aren't really the first things you think of when you think, where do I need to put de-icing, right? You're thinking North Dakota, South Dakota. We've been up there. But actually, some of our first and, frankly, to our customers, most important installations have been in that kind of Midwestern, middle of America band there.
So it's not really icing so much as the amount of power lost, right? I mean, we're becoming really dependent upon wind turbines producing power. Like 60% of the power in Iowa is from wind turbines. So it's really critical they keep spinning. And the icing itself, if you talk to operators, they're not super concerned about the icing. They're concerned about the consistency of the turbine spinning and making sure that they stay online as long as they possibly can. Because some of the wind turbines have a situation where any sort of ice will just, they take the safest assumption and just shut it down. And that's probably not the right model going forward.
No, it's not a sustainable model, especially when, as you say, states are increasingly, and people living there are increasingly depending on this power to keep themselves warm, keep the lights on at the most critical times during these winter storms. The auto shutdown or the manual shutdowns, they aren't a solution, and it's not a sustainable solution monetarily or to take care of the communities that we're trying to serve. So when we look at those issues, that is kind of what, we initially thought this coating would be in use in the aeronautics sector. And then we were seeing these issues crop up more and more. And we thought, oh, well, this could be an application. And then through our testing and our application process, we found that it does help. In fact, the coating works better if you don't do those auto shutdowns. It's actually the movement of the blades actually encourages. It works with the Neinice coating to encourage the ice not to form. So we actually tell our customers, it's actually kind of crucial that you deactivate those auto shutdowns, and you will see these improvements in revenue, power output, everything.
Since you've done some deployments early on, like during this massive ice storm down in Texas and Oklahoma, I'm assuming you've branched out to other parts of the world. What are you hearing from the Europes and those kind of places where icing is pretty common?
We're seeing good results out there. We're seeing repeat customers, which of course we always like to see. We just did an application out in France. We've done some in Sweden and Norway, even an Italy application, northern Italy. and we are partnering with Aerones, obviously, out of Latvia. And we're working on a coating manufacturer and distributor in Germany to try to help that grow and hopefully start getting some real hard data out of those places.
Let's talk about how Phazebreak coatings are applied, the Neinice coating is applied, and sort of what it is. Because I've seen some really interesting YouTube videos you guys have produced. I've seen some things from Aerones where they're doing robot applications. But can you just explain generally sort of what the material is, kind of what it feels like, how is it applied, what's the common situation there?
Yeah, so it comes in a 3-part gallon kit, and it is mixed by the applicator. On the ground, on platform, we've had rope access done, or in the Aerones robot. Our recent application tutorial video we released to help customers that might want to use their own teams without our application team coming out to apply the product. And so basically it's a matter of mixing the materials, stirring them together in the right order. But really, at the end of the day, once it's properly mixed and you've prepared the blade, like you're painting a house, basically, you take painter's tape and you mask out the area on the leading edge. That's where you're usually focusing. Make sure you get a nice, thin, even layer. It goes on as thin as a piece of paper. And you just paint it on like you would the walls of your nursery.
Is there any prep that needs to be done to the blade before the coating is applied?
Yes, so you would want to clean it down with a denatured alcohol. It's generally what we recommend. It's just a light cleaning. If there's dirt or anything that's kind of embedded, sometimes the delivery companies let the OEMs let the blade sit on the ground and dirt builds up on the bottom half that's been in contact with the ground. You might want to take a sander to that or something, nothing too extreme, but just get a clean surface so that the coating can really bind to that.
Get the blades clean, mask them off, and then you're applying the coating with a roller or a brush?
Yes, so you can just take your run-of-the-mill Home Depot 3/8-inch nap roller and put it on a pole. However you can access the blade best. In our example video that we put on YouTube, our applicator used just a step ladder to get up to the top parts of the blade, and you go all the way down, avoiding any sensors or lightning protection units, anything like that you might have. We don't want to interfere with that, but they can work in tandem together. And you just roll it on. Spray is also an option. Spraying is also an option, but it may use more material. So it's really just, it's the preference of the operator and the applicator.
Where is it applied on the blade? I know you said the leading edge, but how far down? How close to the hub do you go? Do you go all the way down to the hub?
We don't go all the way down to the hub. We leave about the last 15 to 20% of the blade uncoated.
That makes a lot of sense. Apply the material where icing is most likely to accrue. If there's damage to the blades in service, most of them have some sort of leading edge erosion. Do you recommend that gets cleaned up before you start putting Neinice down?
Yes, and this is where Aerones becomes our best friend and the operator's best friend, because the Aerones robot is specifically designed to be able to do that type of reparative maintenance on the blade, and then very quickly go back out with our coating loaded into it, and then quickly coat. It can coat the whole blade in 7 minutes with our product, so it's very easy to do that maintenance and then follow up with the coating very quickly on the same day.
All right. And is there any length of time that the coating has to dry before it gets hit by ice or anything else?
Well, so we have to apply the coating in temperatures above 0 degrees Celsius, 32 degrees Fahrenheit. It can't be raining. So we need a dry climate. But it needs at least 24 hours to cure, is what we recommend before you start running the blade again, just to make sure it has that full cure time and hardens. And once it does harden, it is just this shiny shellac that you can hardly even scratch with your fingernail. It's very sleek.
I've seen some pictures of your material. I think maybe with a Next Era, where the color was like a light blue. Is it tinted so you can see it?
So that is by request, and we do that without any extra charge. So our dye is an option that we started doing with Nextera because they wanted an easier way to monitor the coating because it goes on completely clear. You'd hardly be able to tell it was there. So when we add that blue dye, it makes it easier for drone-based inspection. A camera, no matter how good it is not as powerful as the human eye at detecting those minute things. So we just thought, we worked out a system where it makes it a lot easier to detect.
Inspecting the material is really critical, I assume. You want to make sure the coating is still in place. Blades get beat up all the time, right? Leading edge erosion is a thing, but blades get abused. And does the coating need to be reapplied over time? What's the thought there?
Yes. So actually, we just this week, we got some information back from one of our customers from two different wind farms, one in North Dakota, one in Iowa, that kind of laid out how the coating performs over time. We specifically focused on icing events. So in our North Dakota example, the first year after it was applied, it had a 45% power output improvement over the uncoated blades during icing events. The second year, 30%. The third year, 20%. And the fourth year, 0%. So that shows that it deteriorated over a period of about 4 years. And then in Iowa, as you said, very important, 60% of the energy in that state. First year, 25%, second year, 20%, third year, 10%, fourth, 0. So we're able to confidently say that, yes, after about 3 years, and of course, these are both places that are getting buffeted by rain, wind, ice, snow. So it might perform for much longer in a place like in Oklahoma, Texas. We can't say for sure, but if you have severe events, then we would say to reapply every 3 to 4 years is about time to do it.
Well, that seems quite reasonable because that's when you're going to fix leading edge erosion roughly every 3 years if you're on top of it. That would make sense. So the coating itself, once it's applied, how then does it work to keep ice from accruing to the point where the turbine shuts down? What's the magic there?
It's hydrophobic on a basic level, and it's ice-phobic, again, through those phase change materials that interact kind of in the same way, actually exactly in the same way as an icy hot patch or one of those, your hand warmer that you crack and then you put in your pocket. That is also a type of phase change material. This particular one, instead of that cracking action to activate it, it's actually activated by water. So when that comes into contact, the molecules interact in a way that actually heats up the material just enough that it does not want the ice to adhere to it. And again, it's a silicone base, and as we all know, silicone is not the most easy thing to stand on or grab onto in the world. So it has these natural properties. And again, so between those two elements, it just molecularly and through that heat that is generated, it doesn't let the ice really start to form. And once it starts getting too large and starting that real thick rime ice, it kind of naturally just wants to slough off.
So as the ice starts falling off, then you regain all that power back, right? That's the thought.
Exactly. And that's also why you see them turbines recovering much faster as things begin to heat up, as the storm lets up a bit. Then the coated blades are much faster to go through that recovery period of sloughing the ice off and getting back to pre-event levels.
Addressing the sort of the SCADA operational side of this, are any changes needed to get the power back out of the turbine, or does anything need to be done there to keep the turbines running?
Yes, we encourage people to reset that system so that the auto shutdown is less sensitive. We don't push it to the point where you might be damaging your blade, of course, but to dial that back a bit so that the blade can keep turning for a bit longer and encourage that sloughing action that I've been talking about. And, even if an operator isn't comfortable with that, again, you're getting earlier recovery times, you're getting less ice formation early in the event. So you are still going to see an increase in uptime, over the course of the event. And I would say, our theory is, if you're asking somebody, would you rather your turbine be off the whole time or be on for 2 hours longer? I think most people are going to choose the 2 hours longer.
Oh, sure. And so the rotation is really a critical piece of this. You don't want to put Neinice on and then stop the blades and then think that the ice is just going to fall off. That's not the point. The engineering design is such that it needs to continue to spin to get the ice to come off.
Correct. And you're always still going to see some ice formation to a degree. I mean, in these storms, again, our slogan is ice mitigation instead of ice removal. We don't like to use the word prevention because we're not preventing the ice. That's a force of nature. You can't really control that.
Yeah. And what we're seeing on a more global scale is in places where they know they have a significant amount of downtime and a significant amount of ice, those are sort of preordained to have a de-icing system on them. It's the vast majority that are running into this icing situation a lot more than the projections, right? So before wind turbines are installed, there's an environmental analysis done, and they kind of predict the number of days or hours that the turbines are likely to be down. It's sort of like a 5% point. If it's more than 5%, de-icing systems go on. But a lot of the projections are like maybe 1% of the time, 2% of the time. But those are still productive power times that they're missing, which makes sense to put on a coating like yours.
Exactly. And we always like to point out that those de-icing systems, so we've talked a lot about people who don't have any, even a heated or a vibrating blade. I mean, our coating can go on top of the blade. It's not going to interfere with those systems. They can work in tandem, and you could see an even further increase in power output and protection of your wind assets.
Okay, that's an interesting approach. So even for blades that do have de-icing systems and heating systems on them, they still accrue some ice, right? If you watch them, there are places where ice does stick. It's really hard to get a heater out towards the tip necessarily. So putting this coating on will help at least alleviate some of those issues, right?
Correct.
So the deployment of this is starting to get a little bit worldwide. You've done a significant part of the United States at this point, I assume, and you're into Europe. Is there any other places in the world that you're starting to apply Neinice to?
So we've had a lot of interest in Turkey. We've applied in China before. Actually, some interest in places like India and even Northern Africa, where people are asking, can this keep dust off? And can this keep, grime and things from building up? Because that's a huge issue out there. And so we have actually applied, and they've found that with the hydrophobic qualities, that they've also become self-cleaning to a large degree. So when you get a light rain, it washes all that stuff off just naturally. And even just with the movement and its very slick surface that it creates, it is discouraging dust and debris from clinging to those blades, and that thus improving the aerodynamics.
I have seen pictures from various parts of the world where they burn the fields, like we used to here in the States quite often. I think we still do a little bit. And the soot from that just covers the blades. It's amazing how dirty a blade can get. And that soot is sticky, and it is really hard to get off. So putting a coating like this on would essentially prevent some of that soot, debris, stickiness from sticking onto the most important part of the blade, right?
Exactly, and that's the idea that these operators had, and so they brought us to parts of the world that we never expected to be in.
So this is quite the adventure then. It seems like there's more applications for this coating as we go along. And I just want to talk about the Aerones piece for a minute, because I know in our business, which is a lightning protection business, being on the blade and the amount of time we're on a blade is really critical, right? It's downtime. How has the Aerones robotic application piece helped speed up the application time and to get the wind turbine back running again?
Well, two of the critical elements are that the actual wind speeds and weather conditions that the Aerones robot can work under are, there's a far wider range of conditions that robot can work under than manned crews. So in instances where you'd have to tell a platform or rope crew that you have to come down right now, and you lose 2-3 days because of, winds hitting too high of a speed, that Aerones robot can go right up there. The other advantage is that, as it's a robot, they mount it on the blade the same exact way every time. And then an operator in a van down on the ground just guides it along. So you're also getting a consistency and that a consistency and a with the human element. So kind of the best of both worlds, where if anything goes wrong, that human can step in and make the necessary adjustments. But that element of consistency is huge. And then finally, the robot itself doesn't have the issues that human does with the pot life. So our product has about a 1 hour pot life. So that can really be a critical thing when you're doing rope access, doing platform. Not so much on the ground. It's much easier to move around and control for that. Aaron's robot mixes everything right inside of it. And so you are guaranteed the best consistency of the product, a proper mix every time, and then it just applies it within 7 minutes. So you're not worrying about, wasting any material, and you're guaranteed that you're not wasting time mixing the product and waiting for it to react. That's already happening.
Well, Aaron, this has been really interesting. I've learned a tremendous amount about Neinice and Phazebreak. And how do people reach out to you? How do they find you?
Okay, well, they can find us at phazebreak.com. That's PHAZEBREAK.com. They can always find us on LinkedIn under Phazebreak Coatings, and they can reach us at info@phazebreak.com, or better yet, reach out to Dave Rupp, our sales guy. I really recommend reaching out to him. He's very knowledgeable, very kind man. So he's dave.rupp, RUPP, at phazebreak.com. So those are the best ways to reach us, absolutely.
Thanks for being on the program, Aaron, and I'd love to hear more about Phazebreak as things continue on. So we'd love to have you back sometime.
Absolutely. Thank you so much for having me. It's been my pleasure, Alan.